Yes.
Yes, we hear you. Yeah, we hear you. So you are right now online on stream. There is quite a full hall, and we are looking forward to hearing and seeing your presentation. So the floor is yours.
Thank you. Let me share my screen. You see my screen?
Yes, we do.
Yes. So I'm hearing myself again. I'm not sure if there is a way to fix this.
We hear you properly here in this hall, so you can continue. I don't know.
Oh, okay, then I'll try. Yeah. So I'll present the Norwegian AI Factory, which is infrastructure for research and development. I would like to highlight the contributions from my colleague here, colleagues in Sigma2, Gunnar Bo, our director, and Roker Kvam, who is the project owner of the AI Factory, and others in the team. And introducing myself, I'm senior advisor at Sigma2, which is the national infrastructure provider in Norway. I'm also the technical coordinator and benefits realization manager of the Norwegian AI Factory and the service owner of the National Research Cloud. And also I work as instructor in cybersecurity at Northern Illinois University. So about Sigma2, we will have an introduction and also EuroHPC activities where we are involved in addition to the Norwegian AI Factory. So Sigma2 is the national infrastructure provider in Norway, and our mission is to offer high performance computing and large scale data storage to research and higher education in Norway. There are many other players in Norway, but we are the ones with the big computing and the big storage. Universities in Norway, they have their own offerings for computing and storage capacities, but the large high performance computing and storage is mainly driven by Sigma2. The key strategic areas is to provide advanced compute and data services addressing the user needs and facilitator for international research services in addition to cloud-based resources and common components, and combine our infrastructure in Sigma2 with the capability and competencies of the partner institutions, the universities, to achieve excellent research services. This is a more clear way of describing. As you know, this part is called the big head and the other is called the long tail. So the HPC and high performance computing resources, the largest part of the head we get from our partnership in EuroHPC and previous in PRACE, and the one in the middle for our national owned HPC computing facilities and clusters. And here in the long tail, it appears the universities. They have their own HPC clusters. They have their own cloud OpenStack-like systems, but they are relatively small. So on a tier model, so we have the tier 0, international, like we are members of the LUMI consortium, the LUMI supercomputer, which has been for some time the largest supercomputer in Europe. And we are also members of the LUMI AI supercomputer, which will be the largest supercomputer in Europe, of course, for some time. And tier 1 is the national HPC systems, and tier 0 is the institutions. Our customers or users in according to the scientific discipline, as you see here, computational fluid dynamics and geosciences, they have large portion. In addition to material sciences, chemistry, physics, And here is the contribution by users and research institutions. Where our infrastructure live, so we are distributed. We have the NIRD, which is the Norwegian Infrastructure Research for research data. This is the main storage. And the HPC centers in a place called Lefdal Mine Data Center. This was an old mine that is turned into the largest data center in Norway. And we have some of the HPC clusters in Trondheim and in Tromsø, the University of Tromsø. And our TSD, Tjeneste for Sensitive Data, this is the sensitive data services, the HPC for sensitive data. This is located at the University of Oslo, but it is owned by Sigma2. And here our BETSI cluster with some statistics, and we got our new Olivia cluster that is actually recently become operational. And this is the image of it in the Lifdal mine. And it is, we have about 500 Grasshopper GPUs from NVIDIA. This is how the Lifdal mine looks, a bit scary from outside. It's a cave, and this is how it looks from inside. So it looked like an ant colony. And these are the data centers here, and the different companies are there, and the actual machines are inside containers. This is very close to the beach, and this is how the cooling comes from. This is our building in the Lefdal mine area. So talking about the National Infrastructure for Research Data, NIRD, current capacity of 62 petabytes. This is our storage service. It is divided into the NIRD data peak with the performance of 209 gigabyte per second, NIRD data lake with the performance of 66 gigabyte per second, and also over S3, 27 gigabyte per second. So as we know, S3 is the easy way of communicating, but it is also a bit slow. Also, we have the archive service, archive.sigma2.no, certified core trust seal. This is part of the data lake offering. For EuroHPC, we know what EuroHPC is, and the current cluster that we are part of in EuroHPC, it is LUMI supercomputer, and this is the LUMI consortium. And then we have these AI factories. So the AI factory initiative is to promote compute and data and talent. So we joined forces with some of the members of the LUMI consortium and formed the LUMI AI Factory consortium. So these are the current countries: Finland, Norway, Czech Republic, Poland, Denmark, and Estonia. The total budget of 580 million euros. And mainly there are these three parts: LUMI AI, multi-IXA flop computer for ML training tasks, and this is over 6 times more powerful than the current LUMI supercomputer. The AI Factory data center, which is a collection of FTEs, about 100 FTEs with over 3,000 PMs around the consortium. LUMI IQ, which is a quantum computer, accelerated partition. The plan is to have it with 300 qubits to be very ambitious to reach 2,400 qubits. So the main vision is to create a service portfolio, comprehensive and accessible service infrastructure for powering AI startups, SMEs, academic researchers. So the focus here is not mainly academia, but more towards industry. And leverage the established LUMI system, install the new AI optimized supercomputer and the experimental quantum computing platform. And of course, create the world-class computing environment and access to the new data sources. The pillars, the three pillars is the AI optimized supercomputer, the hardware, the service center, and the quantum computing. So two hardware, the quantum computer, the supercomputer, and the service center, which is a people effort. This is the timeline. This is the current where we are now with the LUMI supercomputer. And this is where we expect to have the LUMI AI supercomputer. And this is where we expect to have the LUMI IQ quantum computer. So these are the services, computing capacity in large scale, compute support all the way, friendly human support from getting started to deep AI methods and scalability, and supported ML ops environments and recipes. This is the software stack, and this is what is interesting technical-wise. So LUMI supercomputer used to be a traditional HPC computer, a traditional Slurm computer. It has different partition, the CPU partition, the GPU partition, other partitions, but it is still one Slurm computer. The LUMI AI will be multi-tenant system. So users will be able to run their own Kubernetes clusters, for example. They will have orchestrators. The batch jobs on the batch scheduler will be part of the platform layer, but the other platform layer parts will contain custom platforms, orchestrators, where you can have Jupyter Hub and ML flow, and then the compute environments on the top, containers, customized compute environments, easy build, and then users can access through different ways. You have the experienced users who know what Slurm is, they know what is MPI is, and there are other users who don't know what Slurm is, they don't know what is MPI, they don't know what is HPC, and they are not interested to know. And those are the mouse clicking users. They like to get a nice interface, nice pictures, they click with the mouse and they get whatever they want. They also will be part of this. And the compute environment should be abstracted completely from them. Is their workflow running on a compute node, bare metal? Is it running on a virtual machine on the top of a compute node? Is it running in a container? They shouldn't care. They just need to get the compute power with nice interface, and this is it. So the people type of services, training, consultation, focus on AI adoption, and also the AI Factory Hub engage the next generation talent. So this is what is called the LUMI AI Factory Service Center. Data has a very important aspect. So giving access to data. Data here can mean data sets that can be used for training AI models. Data sets that can be used for computing. So LUMI AI is not going to be dedicated just for AI workloads, but it will be optimized for AI and ML workloads. But you can definitely run other workloads. So data sharing, and we have the other type of data, which is something between data and software, that is the AI models. AI models are not huge. The largest AI model that I'm aware of is about 4.5 terabytes. You don't get an AI model that is 10 terabytes. I have never heard about that. But AI models are special type of data. Version control is very important. Who is allowed to train the model is important. So this is part of the data services, sharing of these models. And there are some selected data sets from different repositories that to be available for using and training the models. And these are the work packages. From customer interaction, work package 1, training and skills development, work package 2, customer engagement, work package 8, communication and outreach. Then the LUMI AI Factory operations, work package 4, the software, work package 5, data, work package 3, expert support for AI, work package 7, business development and exploitation. Then the networking, the work package 6, the networking between the ecosystems who are member of the consortium, and work package 9 is the management work package. These are the work packages which are part of the LUMI AI Factory. The Norwegian AI Factory is the Norwegian part of it. To avoid any confusions, I give you this table that defines the who are the members and what is the PM distribution. So as you see, CSC is the biggest monster here for the LUMI AI Factory project, and Sigma2, this is us from Norway. We have 318 PMs, and these are the total number of PMs, 3,848, about 100 FTEs over 3 years. For the Norwegian AI Factory, first, it is something that is in our mind similar to the NCCs. This is how the NCCs are composed, and this is how the AI factories. So there is a lot of similarities between NCCs and AI factories. The Norwegian AI Factory, which is similar to the Norwegian NCC, is led by Sigma2, and it includes the Norwegian Research Infrastructure Services. It means that we have a lot of the personnel from the universities. So we have a few technical personnel in Sigma2, but most of the technical personnel in the Norwegian AI Factory are from the universities. And also additional partners, for example, DigDeer, which is the main responsible for accessing data of public administration. And here we are taking a step out of academia, so we're reaching out to other players. So the alignment of the strategies linked to the national AI strategies, to the national data strategies and policies, very important, linked to the national programs for supporting startups and SMEs, and support public administration bodies in AI uptake and use. So the services will be mainly for the Norwegian AI Factory. So this is well aligned with the LUMI AI Factory, but what we will do in Norway, because the Norwegian AI Factory, after the end of the project that we have with the Finns, the Norwegian AI Factory will not come to an end. It will continue as streamlined service lines. So we will focus on access to data, software environments, user training, services to SMEs and big industries and public bodies. So the roadmap, how we are going to go with the Norwegian AI Factory, we had a project that is called NAIC, Norwegian AI Cloud. This was led by universities, and Sigma2 was a member of it. It was something similar to the AI factories, from infrastructure to platform to software to people and training. So we will be facing this project, learning from the experience of it in the LUMI AI Factory perspective and the Norwegian AI Factory. And we will establish, in the process of establishing a central AI model repository and deploying a new cloud platform region in Lefdal mine. We are currently having the compute services, the HPC services, and a bare metal Kubernetes cluster. So we will deploy a large-scale cloud platform that will include the Kubernetes cluster and OpenStack cloud. Currently, this is the Norwegian AI Cloud that I talked about. These are the universities plus Sigma2. And we are basing our orchestration on Valdur. I think Valdur is well known now. And this is the interface that the user gets. The user asks for a specific amount of resources for specific use cases, and then it gets orchestrated to the cloud region where the matching resources are allocated. And the accounting depends on how much the quota the user has. In addition to that, we have access from the Norwegian AI Cloud to Google Cloud and to IBM and to other commercial clouds. IBM, they have this service, try before you buy, and it is provided for sysadmins to try the new hardware. So we will also support in the way supporting cloud native HPC gateway to submit jobs to HPC from Open on Demand from Jupyter notebooks, and also make a federation between Kubernetes and Slurm. There is a platform called Slinky for this integration. Shared toolkit repository and central user portal across services. And this is what we are planning to have a Valdur-based orchestrator that has the Open on Demand to the HPC marketplace with access to services to Kubernetes, and all of this connected to the storage. And the orchestrator can orchestrate this workload still to the universities.
I don't know what happened. Do you hear each other? Do you hear us? Because there is some. I think the picture and the sound froze a little bit. Do you hear us, Mr. Abdulrahman Azab Mohamed?
We are building the EOSC node in Norway, and also connect to the NCCs and to EuroHPC. Yes, so this is in brief what the Norwegian AI Factory is and what LUMI AI Factory is and how we communicate and align.
Thank you very much. Thank you very much, Mr. Abdulrahman Azab Mohamed. For a couple of seconds, we've lost you at the end, but I think we got the whole point of your presentation. Thank you very much for presenting us the case of the Norwegian AI Factory. Because we are already quite behind the schedule, maybe just a tiny short question. I'll take one. So Mr. Imamagic from the Croatia has raised his hand, and there will be one question for you.
Hi. Briefly, the AI Factory Services Horizon project lasts 3 years, if I remember correctly. And in your slides, you were really optimistic that it's going to be streamlined and continue working after those 3 years. How are you planning to fund it after those 3 years?
Well, in the review of the AI Factory that happened in Luxembourg, I think 2 weeks ago, they have raised this, and they said clearly that you should support yourself. You should plan to establish legal entities, companies for the service centers, and should go more to industry. So they are urging us to start making money to support ourselves. So we got this signal, and what we think the case will be, now the funding for the AI Factory, it is 50% from the Commission and 50% from the Research Council. So the 50% of the Research Council probably will remain. It might come from the state directly, but the other 50%, it has to be from services that we offer and make money. As a public company or a government-owned company, we are not allowed to make profit. And this will be the case, I think, for all of the infrastructure providers. But we can make money and spend it on the hardware. So this is the view. But anything specific, I can say exactly how we are going to continue. This is still unknown.
So basically, there's no EuroHPC 3 or 3 phase for AI factories. You only get those 3 years, and if there's no sustainability afterwards, well, yeah, you shut it down.
Yeah, so there might be, but we cannot rely on that, because we got signals that when they are telling you should fund yourself, this is a signal that should be understood.
Thank you very much. I can't take any other question, but maybe Mr. Abdulrahman Azab Mohamed, can you maybe share your screen with the last slide where your contact is, so that people can save your contact and maybe send you the questions via mail. So, yeah. Thank you. With this presentation, we will conclude today's event on the supercomputing. I really thank to all the speakers and to all the participants to share your insights. We heard so many interesting things from the HPC and AI innovations to national AI factories and applied research across Europe, and how computing power and advanced algorithms are driving science, industry, and society forward. Tomorrow we continue with the Connecting Science 2025 event, starting with opening addresses and a UNESCO perspective on open science, followed by roundtables on research infrastructure and supercomputing's global impact. It promises to be another full day of learning, exchange and collaboration, highlighting how open science and high-performance computing are shaping the future of research. So thank you very much for your attention for today, and I really wish you a pleasant evening here in Ljubljana. Thank you very much.